This video will discuss central F versus a non-central F. So in analysis of variance, we begin with looking at the sum of squares. And so this SS is the sum of squares. And this is really doing the initial calculation of the variances and the shifts in variance for the whole group. So your total is going to be your whole group. Your sum of squares for between is between groups. And then your sum of squares within is the variance or the sum of squares calculation within each one of the groups that are being compared. Then we need to calculate our degrees of freedom. So we need to remember that our degrees of freedom are really all the little bits of information that we have and can use to run an analysis. Now it's very important to make sure that we are calculating our degrees of freedom, not only to understand computationally what's happening on the back end of ANOVA, but also ensuring that our degrees of freedom are not getting low enough where they are going past 1, so becoming negative or 0, and taking us into territory where we have very high potential of getting a type 1 error, where a type 1 error is a false positive statistical result. So again, for degrees of freedom, we need to see the degrees of freedom for the total group, the degrees of freedom between the groups that are being compared, and the degrees of freedom within each one of the groups. And so for our total group, our degrees of freedom are the total sample size minus 1. Our degrees of freedom for between the groups uses the number of groups minus 1. And for within, we are looking at really both the groups and the total sample size, and making the assumption that each of our groups have equal or near equal numbers of participants. And so for within groups, we take our sample size minus the number of groups that we have. So then once we have our sum of squares and our degrees of freedom for the total for between and within, now we can get our mean square. And so this is mean square values. And our mean square values are our sum of squared divided by our degrees of freedom. And we would for this also get a total value, a between value, and a within value, but we're only using certain ones to get our final calculation, or to use in our final calculation of our F statistic. So for the sum of squares, you're really using and then this is to really emphasize what's going into these mean square calculations. So your sum of square total is using each individual score in comparison to your grand mean. And then they are being squared, so they have the square value here. And for the degrees of freedom, you're looking at your total group and subtracting 1 to get your degrees of freedom for the total. Then these two together, so the sum of squares divided by the degrees of freedom, would give you your mean square for your total group. Then for between, we are now looking at each of the group means, because for between, we're really looking at the differences of variance between the different groups. So you're comparing each group mean to the grand mean of the whole group, and we have our square value here for our sum of squares. And then for our degrees of freedom for between, we are looking at the number of groups minus 1. And so then we can do our sum of squared divided by our degrees of freedom to be able to get our sum of squares between or our mean squares between value. And lastly, we have our within values. And so for within, because this is within each one of the groups, we are looking at each individual score compared to the group mean that that individual is in. We have our square value, so we're doing a sum of the squares. And then for degrees of freedom now, we are looking at um, what is the sample size for the entire sample in relation to the number of groups that you have. So you can take the total sample size for the entire group and subtract the number of groups that are included in the analyses. So the F ratio is made up of the mean sum of squares for the between values and the mean sum of square for the within values. And so this is using the variance for the population to do this calculation. So essentially what we're doing is we're taking the distribution within the sample that you're using for ANOVA, and we are making the assumption that it is fitting to a population distribution, and then using this calculation of variance to look at the between variance in ratio to the within variance to get our F ratio or F statistic. So the calculation of this F ratio has this F distribution. So any of your F statistics are going to fall within this F distribution. This is the sampling distribution for any of the F ratios that you could get. And there is this small portion, and this is about 5%. So this is like at a 5% area where you have the probability of statistical significance. So when you get an F statistic that's up here, this is where you know that you have statistical significance. Now the F distribution is positively skewed, and it's usually positively skewed in relation to 1. So the majority of your F statistics are found to be less than 1, but then when you start getting above 1 is when you start getting statistical significance, and in this high 5%, where you have usually these F statistics are above 3 to 5 and higher, then you're getting statistical significance. So the central F distribution is based on a standard F using the population, and it's setting that standard where you have the majority of your distribution to be less than 1. Now a non-central F is when you have a treatment included. So this is the actual F that's being calculated when you're using your data within an ANOVA analysis. And so what's happening is we are comparing the central F to the non-central F. And in that comparison, you get a couple of different things. You get the comparison, from the comparison, you get what is the error of your analysis, and you also get the significance of your analysis. And so if we know that the bottom 5% of the central F is where we will have statistical significance, then we extend that into our non-central F distribution, and we can establish what are the F values that we need to obtain to have a statistically significant difference between the groups. Now, the important thing to remember is this is just establishing statistical significance in saying that there's at least two groups within your sample that are statistically different. It's not telling you which of those groups are statistically different, nor is it telling you if your effect of the treatment or the effect related to that difference between group means is actually large enough to be practical and practically significant.